Alright, ladies and gentlemen, today's lesson is comparing and scaling 1.3. We're going to be doing our homework today as well, and our learning target for today is that I can use ratios, percents, and fractions to make comparison statements. Let's go ahead and get started on today's lesson right away so we can get right to our work, get that done, and learn some more stuff about math. Okay, for this lesson, what we're going to be doing is we're going to be comparing some of the largest trees in the world. The giant sequoia, the coast redwood, the swamp chestnut oak, the Florida crosspedium, hope I'm saying that right, and the white oak. Now, there's three things that we're going to be measuring in this case: the circumference, the height, and the spread. Now let's talk a little bit about what that means. The height of this tree is just that. From top to bottom, how big is it? Okay? So if I was to take a tape measure and take it all the way to the top of the tree, what would that be? That would be the height. The circumference is, let's say I started on one side of the tree and I took a big old belt and wrapped it all around the outside of the tree. The distance to walk around it, essentially. Essentially, the perimeter of the tree would be the circumference, or C, the circumference of that tree. And then, if I was to walk from one edge of the branches to the other edge of the branches, that would be the spread, or diameter. Okay? So circumference is walking around the tree, the height is how tall it is, and the spread is, if I was to stretch my arms out, how big would this tree be? So let's get started on our questions. What we're going to be doing is we're going to be answering these questions and deciding if they're true and finding ways to prove that they're true. For our first one, how many coast redwood spreads does it take to equal the spread of a white oak? So we need to find a couple of different things. First, we need to decide the spread of the coast redwood and the spread of the white oak. Now the spread of the coast redwood is what? The spread of the coast redwood is 80 feet. So I'm going to put the 80 right here above the coast redwood, kind of as like a little note to myself that that is the coast redwood spread. And now I want to know the spread of the white oak. The spread of the white oak is 119. Now 119 is a lot bigger than 80. And I'm comparing the coast redwood to the white oak. I want to know how many of this will make that. So basically, what number times 80 will give me 119? I don't know that middle number. How can I find it out? Well, I can take 119, and a calculator would be very handy for this, and divide it by 80. And when I do 119 divided by 80, the answer I get is what? I get 1.487, but how about we round that to about 1.5? So it's about 1.5. About 1.5 of the redwoods make a white oak tree. Okay? Which means that for every 1 foot of redwood, I get 1.5 feet of white oak. I have a ratio there. I can make a fraction from that. I can make a percent from that. I can do all kinds of amazing stuff with that. But now I know that relationship. Okay? The spread of the white oak is greater than the coast redwood by a ratio of 3 to 2. Well, I have to prove if that's true or not. To prove if that's true, I'm going to go back to that ratio. And what I get is, if I had the white oak come first, Reverse that, I get 1.5. And I get the Coast Redwood is 1. Well, I need to make that so that it's equal to 3 to 2. So I'm going to make this going into 2. So what do? Well, I would have to double to go from 1 to 2. And I need to double the other one too, because it works kind of like a fraction. And 1.5 times 2 is 3. I get 3 to 2. So is this true? Yes, it is true. Now, number 3. It's kind of on the bottom here, but I think we can fit it in. The difference between the height of the coast redwood and the giant sequoia is 46 feet. Okay, so I need to basically find the difference. I need to find how much taller the coast redwood or the sequoia is. So I go and I find the heights. Let me erase my little notes here. Now the coast redwood is 321 feet tall. The giant sequoia is 275. So I take 321 minus 275 to find how much taller the coast redwood is. So, clearing that out, 321 minus 275 gives me 46 feet. Exactly. So is this true? Yes, this is true. Okay, number 2. The spread of the white oak is greater. Oh, I did those already. 4. How many giant sequoia spreads does it take to equal the spread of a swamp chestnut oak? Well, first off, how big is the giant sequoia's spread? Let's find that out. The giant sequoia's spread, so I got interrupted a little bit. How many giant sequoia spreads does it take to equal the spread of a swamp chestnut oak? Well, let's go ahead and find that out. The giant sequoia spread is what? The spread of a giant sequoia is 107 feet. So let's put that in here. 107 feet times some number is going to give me the chestnut oak. The chestnut oak has 216 feet for its spread. So 107 times some number gives me 216. How are we going to solve that? Let's take 216 and divide it by 107. Once we divide that by 107, we should get an answer that gives us about how many sequoias it will take to make a swamp chestnut oak. Go ahead and do 216 divided by 107. We get about 2.01. So for all intents and purposes, about 2 times as big. So now we have this question. The spread of a giant sequoia is less than 50% the spread of a chestnut oak. Well, we need to create a fraction. Okay? So we take 107 and we divide it by 216. And we should get a decimal. What decimal do we get? Go ahead and punch that into your calculator. We get 0.49, which if we make that into a percent is about 49%, which is about 50%, just a little bit less. So the answer is yes. It is less than 50% of the spread, technically. Okay, for this last question, the circumference of a swamp chestnut oak is 3/4 the circumference of a white oak. Well, let's set this up. We have the swamp chestnut, and we have the white oak. Go ahead and make that into a fraction. What do we get? So, the swamp chestnut is 23 feet. The white oak is about 31 feet. We want to know if it's going to be 3/4 the same size. So what I do is I take that fourth, What can I divide 31 by to get 4? Try this for me. Try 31 divided by 4. What do we get? 31 divided by... Okay, if we take 31 divided by 4, we get 7.75. Which means if I do the top and bottom by 7.75, if I do 23 now, divided by 7.75, I get 2.94, which essentially rounds to 3. So is it about 3/4? Yes. So ladies and gentlemen, what I want you to do now is answer in your own words part D. When a problem requires a comparison, how do you decide whether to use differences, ratios, fractions, or percents? Go ahead and tell me when you think it makes sense to use a difference like more than, a ratio like 2 to 1, a fraction like 1/2, or a percent like 35%. Go ahead and tell me the best use for these items, and then you're free to start your homework. Have fun.